Hi, welcome to Finding Derivatives of Inverse Functions. My name is Kitty Morgan, and I'm a math nerd, and I love calculus, so I'm making this video for you. So, what do we know about inverse functions to begin with? If we'll start there, I think this will help us find that derivative part. So I think of an inverse function as an undo function. And when I say that, let's look at this example. If I had x squared minus 4 equals 0, and I ask you to solve it, you would add 4 to both sides, and that would give you x squared equals 4. And then you would ask yourself, how do I solve for x, or how do I undo x squared? And you undo x squared by taking the square root of that side and the square root of that side. And when you do, you take the square root of x squared, that undoes that, and you simply get an x. And of course that yields plus or minus 2. So inverse functions, to me, undo one another. When you talk about inverse functions, you have to talk about some different symbols. So let's talk about the original function. And for our case, we're going to call the original function, I didn't know how to spell original there for a minute, f of x. And we're going to call the inverse function, let's change colors on that. We're going to call the inverse function this weird symbol, which is a -1 in between the f and the x, and that does mean inverse. And when you read this, you don't say f -1 of x, you say f inverse x. And for today, we're going to call that g of x. And this is not always the case, just in our examples we're going to use. So g of x is going to be our inverse function, f of x is going to be our original. So this symbol means inverse. In original function, you will have the point AB. And original and inverse functions, they switch their x's and y's. So the point AB would be on the original function, and the point BA would be on the inverse function. So what you have done probably so far is your teacher's giving you something like y equals 3x minus 4. And they've asked you to find the inverse. And so what you do is you switch x and y, because they switch x and y, and you solve for the new y, and that's your inverse function. That's probably what you've done, something like this so far. So we would say that x plus 4 over 3 is the inverse function of 3x minus 4. And if you wanted to prove that, we use some very cool symbols in math to show that functions are inverses. Now notice that I put a function x squared inside of the square root, and it became a simple x. So the definition of an inverse function is when you actually put a function inside of another, and when you do, you simply get x. So they kind of undo one another, very similar to the thought process of addition and subtraction. You know, like to take this 4 over, I added 4 to both sides. So addition undid that subtraction, that kind of thought process. So every function needs an undo function or an inverse function so that you can solve for the x inside. So this is actually the definition of an inverse function, and it is that if you take a function and put it into the x of another function and the result is a plain x, then those two functions actually are inverses. And so if I took x plus 4 over 3 and I put it into the x of this function, if I put all of that right there, and put it into that x, it would yield a simple x, and that means that they are inverse functions of one another. So we're going to use this definition of the inverse to talk about the derivative of inverse functions. So I am going to make sure we label some things first, okay? And for this, we're going to label f of x as the original function, and we're going to call g of x the inverse function. We're going to use that symbolization, f, with a -1 up there, but we say f inverse of x. Okay? We're going to use that to show that. Now the whole thing that we're trying to do is we're trying to find the derivative of the inverse function. So what we're trying to do is to find what is g prime, because that's the derivative of what we've called the inverse function. That's our goal today. So we're going to use the definition of inverse functions, and hopefully when we go through this derivative process, we can determine what g prime is equal to. So if you take the derivative of a composite function, and it's composite because g of x is inside of f, then you have to take the derivative of the outside, leave the inside alone, and then you have to take the derivative of the inside. That's the chain rule. And the derivative of x is simply 1. All right, so now we're trying to find g prime of x. So I see g prime of x. There it is. Woohoo! So I'm going to solve this statement for g prime of x. And when I do, I get g prime of x is equal to 1 over f prime at g of x. And I'm going to say, guys, that's a little weird looking for me. Now let me erase this little line. I don't think that's a division. That's a lot of stuff for me to see. So you know what I'm going to do? I'm going to go back to our original thing when we talked about points. So we know if the point A, B is on the original, then the point B, A is on the inverse. All right? So let's get very particular. I'm going to say this. I want to find g prime of B. And so if I want to find g prime of B, this is going to help us relate this a little bit better. Then what is, I'm putting a B everywhere, what is g of B? Well, this is the x. What is the y that goes with g of B? And that would be A right here, because this is g of B is A. So I'm going to substitute in right here, instead of g of x, I'm going to write A. So the relationship between the inverse and its original is that they are reciprocals at those switch points. Like the point is BA on the inverse, but it's AB on the original. So they are reciprocals at that point. All right, so let's go and look at an example of that, because that's kind of cool. I want to see that. So let's take somebody that we know that's very simple, and let's look at f of x being x squared. We're going to choose an easy point like 3, 9, and we're going to let g of x, our inverse, see, we know what the inverse is. Sometimes we will not know that, but in this case we do know that, so we're going to just go ahead and see if we believe what they're telling us here. So g of x would be square root of x, and we would use that point. We're going to switch those, right? So we're going to use the point 9, 3. So we're saying if the last thing we said was true, they should be reciprocals of one another. So if you take the derivative of f, I'm going to do that in green, sorry. If you take the derivative of f, you get 2x. And that's a real simple derivative, right? And then we want to see what the slope is at 3. Slope of that tangent line. So if you put, if you put a 3 right there, you get 6. So what we're saying is, if we want to find, and I'm going to write it at the very end because this is what we should end up with. What we're saying is that g prime at 9 should be equal to 1 over that. Okay? That's what we said in our definition of our derivative over here. That g prime at 9 should be equal to the reciprocal of the original function's derivative at the other number, at 3. Okay? So I actually can find the derivative of this guy because I know how to do that. So I'm actually now, this is what I think the answer is. I'm actually now going to prove it and see if that's right or not. So let's see. Oh, hold on. So first of all, if I'm going to take the derivative of the square root of x, I need to rethink about it. So this is my thinking cloud, as x to the 1/2 because I know how to do the power rule. So I know that g prime of x is equal to, take that 1/2 down and subtract a 1/2. So I'm going to write that 1/2, subtract 1. And when you do that, you get 1/2 x to the negative 1/2. Now I kind of have to put all this together in a nice little fraction for me. And so the way I think about it is I write a fraction bar. The 2 is already down there. And the negative exponent indicates that this x should be on the bottom raised to this power. But we know that this power is a square root. So all this really means is that the square root of x needs to be on the bottom of the fraction. And that just leaves us a 1 up there. Okay? And so I want to find g prime of 9. And I'm thinking, according to my rule, it should be 1/6. So let's see if that really works. So I'm going to put in 9 in for x, and the square root of 9, oh my gosh, it's 3. What is 2 times 3? Woohoo! So it really did work. So, this was not as easy as just taking the derivative of this and getting 2x and plugging a 3 in. So I don't have to go through this step every time if I know what the derivative of the original is at the other point. Now notice the question is g prime of 9, but I plugged in the derivative of the original at the 3, not the 9. And that's the relationship. They are reciprocals. If you'll think about a graph, and this is going to be really rough, so be nice. You got x squared. Whoops. Let's go through the origin. Look, there's the origin. And then you got square root of x. Think about it. 3 is here and 3 is here. And that would be really a steep slope, being 6. And then on your square root, it should be really kind of flattish because of the square root graph. So you can kind of see that they are, this one should be really big and that one should be really small, and they kind of are. So they are reciprocals at those points that they reflect across. And I don't know if you do much graphing in your inverse stuff, but these graphs are reflective across y equals x. Oh, get it? Switch y equals x. And so those points right there have reciprocal slopes. All right? So this is the end of video 1, kind of explaining that. In video 2, I'm actually going to work some problems with a worksheet that your teacher has available to her. So I hope to see you in video 2. Thanks.